Let us consider a person standing on a scale. The force on the person by the scale will be F scale upward direction. The force on the person by the gravity, because person has the mass m, he experiences the force due to the gravity, mass times the gravity. F net will be sum of all forces. So F net is equal to F scale minus mass times the gravity. So F scale is equal to F net plus mg. So F net value is mass times the acceleration. We have a mg, or I can write as mass times a plus 9.8. I didn't take the g value negative 9.8 here because I have already taken the negative sign for the g here, so I don't want to put the negative sign again. Let us say an object of mass m, a person, let us say a person of mass m 20 kilogram standing on a scale in a lift. In the first case, if the lift is at rest, that means acceleration of the lift is 0. The weight of the person will be mass times the gravity. The mass is 20 kilogram, g value is 9.8, so you're gonna get the weight of the person 196 Newton downward. The scale, the reading, so we have the formula mass times a plus 9.8. We're gonna get the scale reading, the how much force the scale is applying on the person upward direction, that is 196. If you look at here, the scale reading, the weight of the person, both are same, means here a value is 0, that is why scale reading is equal to the weight of the person. That means the apparent weight is equal to the actual weight. Okay, let us see the second case. Let us assume the lift is moving upward with the 2 meters per second square acceleration. So the weight of the person is the same. The gravitational force on the person is the same. 196, 196. It's not gonna change. That is the actual weight. But the scale reading, it's gonna change. So if you take the weighing scale to the lift, if you stand on the scale, if it is accelerating upward direction, you're gonna see the much bigger reading than when it is at rest. That means here we have a value 2 meters per second. You can put the a value here. And mass 20 kilogram. You can put the 20 kilogram here. And g value 9.8. You will get scale reading 236, which is bigger than the 196. That means your apparent weight is greater than the actual weight. Then let us consider third case. The lift is moving down, so the acceleration, let us say minus 2 meters per second square. The weight of the person is the same. The gravitational force on the mass m is the same, 196 newtons. But the scale reading gonna change because the lift is accelerating downwards. So if you substitute the a value minus 2 here, and you're gonna get the scale reading 156 newtons. That means the apparent weight 156 is less than the actual weight 196. So when the lift is at stationary, if lift is at rest, If lift is not moving, there is no acceleration, there is no net force. If the lift is moving upward, the spring applying more force on the person. So as the lift moves up, so you will see the reading increasing on the scale. If the lift is moving downwards, spring scale reading will goes down. Or let us say if the string of the lift is got broken, then the lift will free fall, right? Lift will free fall. So acceleration of the lift will be minus 9.8. It's a free falling object, right? So if you substitute this minus 9.8 right here, you're gonna get F scale reading 0. What does it mean? When the lift is free falling, the person and the scale both gonna free fall. That means there is no force of the scale on the person. So that means the scale will show 0 reading, that we call weightlessness.